For all of human history, discovery has been a human story. A story of patience, struggle, and those sudden, brilliant flashes of insight. It's a story that moves at human speed. For centuries, we have painstakingly mapped the world around us. One experiment, one failure, one lifetime at a time. But what if I told you that in just the last few years, a new kind of mind has joined the search? A mind that doesn't sleep. A mind that can test a million ideas in the time it takes us to have one. An intelligence so fast and so alien, it's starting to find secrets of the universe that were hidden in plain sight. This isn't a story about robots in a lab. This is the story of how artificial intelligence is triggering a new scientific revolution. A revolution moving so fast, we are discovering a new reality. To understand this revolution, you first have to understand the race we were losing. A race against evolution itself. For decades, we've been locked in a war with an ancient enemy, bacteria. And for a while, we were winning. Our discovery of antibiotics was a miracle. But that miracle is running out. The bacteria are fighting back. They are evolving, becoming resistant to our best drugs, creating terrifying new superbugs. In the US alone, a bug called MRSA infects 80,000 people and kills more than 10,000 every single year. The World Health Organization calls another, Acinetobacter baumannii, a critical threat to human health. Meanwhile, our pipeline of new drugs has run dry. The traditional way of finding a new antibiotic is a brutal numbers game. A chemist might spend their entire career testing thousands of compounds, just hoping for one that works. It takes 10 to 15 years, costs over $1 billion, and 90% of drugs that enter clinical trials fail. The bacteria are evolving in years. We are discovering in decades. We were falling behind. We needed a new weapon, and that's where the new mind comes in. In the last few years, scientists began feeding everything we know about chemistry and biology into deep learning models. They showed the AI millions of chemical compounds and taught it a simple lesson. This one kills bacteria, this one doesn't. The AI wasn't just memorizing, it was learning the fundamental language of molecular warfare. It was learning to see the shape of a molecule and predict its function. And then, they turned it loose. Scientists at MIT and McMaster University were hunting for a weapon against that deadly hospital superbug, Acinetobacter baumannii. They trained an AI model and then gave it a library of nearly 7,000 new compounds to analyze. The analysis took 1.5 hours. Out of those thousands of molecules, the AI identified 240 that it thought might work. When the scientists tested them in the lab, they found a completely new, incredibly potent antibiotic they named abaucin. In tests on mice, it completely suppressed the infection. Think about that. What would have taken a team of humans years of painstaking work, the AI did in an afternoon. It's like going from searching for a needle in a haystack by hand to having a magnet that only attracts needles. But that was just the beginning. Because the next generation of AI isn't just finding things we've already made. It's creating things that have never existed. Scientists at the University of Pennsylvania are now using generative AI, the same kind of AI that creates images from text, to invent entirely new antibiotics from scratch. They start with digital noise, pure static. And the AI, guided by the rules of chemistry and biology, begins to shape that static into brand new molecules. Molecules that evolution never tried. One of the lead scientists describes it like adjusting a radio. You start with static, and then eventually the melody emerges. The results are stunning. The AI has already designed and synthesized molecules that, in animal trials, work just as well as established FDA-approved antibiotics with no detectable side effects. The goal, they say, is to compress the antibiotic discovery timeline from years to days. This isn't just a faster way of doing science. It's a new way of thinking. And it's not just happening in medicine. It's happening in the very fabric of our physical world. Every major technological leap in human history, from the Bronze Age to the Silicon Age, is a story of materials. Better materials are the bottleneck for our entire future. We need new materials for higher capacity batteries, more efficient solar cells, and to capture carbon from the atmosphere. Traditionally, discovering new materials is a slow, almost alchemical process of trial and error. You mix some elements, you cook them, and you see what you get. It's a process that has given us maybe a few 100,000 useful materials in all of human history. But now, AI is exploring the world of materials at a scale that is difficult to comprehend. Researchers at Google DeepMind created an AI called GNOME, Graph Networks for Materials Exploration. They fed it the data from every known stable crystal structure humanity has ever discovered, and then they asked it to predict new ones. GNOME identified 2.2 million new stable materials. That's not a typo. 2.2 million. It's a tenfold increase over the entire history of human chemistry, discovered in a matter of months. Of those, hundreds have already been created in the lab, proving the AI was right. And just like with drug discovery, the next step is creation. AI tools like Microsoft's MatterGen are now designing materials from the ground up based on the properties scientists want. You can literally give it a prompt. Generate a material that is as strong as steel, but as light as foam, and it will design the atomic structure to make it happen. This is a new paradigm. We are moving from an age of discovery to an age of design. So if AI can discover new drugs and invent new materials and do it 1,000,000 times faster than we can, what does that mean for the human scientist? Is this the end of the story of human discovery? The answer is no. It's the beginning of a new one. AI is not a replacement for the scientist. It is the most powerful instrument they have ever been given. It is the ultimate lab assistant. It can run 1,000,000 failed experiments in a simulation, so the human only has to run the one that works. This is what scientists call the lab in the loop. The AI generates predictions. The humans test them in the real world, and the results of those tests make the AI smarter. It's a partnership. The AI is a master of what? It can see patterns in vast data sets that no human ever could, but it still needs a human to ask why. And most importantly, to ask what if. AI didn't decide to cure superbugs. A human did. AI didn't dream of a future with better batteries. A human did. The scientific method isn't being replaced. It's being supercharged. We are entering a new age of discovery, a powerful symbiosis between the relentless, logical power of artificial intelligence and the one thing it will never have, human curiosity. The biggest discoveries are still ahead of us, and they will be found not by man or machine, but by man and machine, exploring a new reality together. Thanks for watching. If you found this as fascinating as I did, hit that like button and subscribe for more stories about our rapidly changing world. See you in the next one.